Hello everyone, welcome to 1000 Math 7. This is the fourth part or part 4 of the first chapter, and today we'll be learning a very interesting topic, that is Venn diagrams. Okay, now why did I say interesting? Because today we'll be drawing some diagrams for sets, and diagrams as always is very fascinating and easy, right? So let's get started with the chapter today and try to recall what is a set. What is a set? Set means a collection of objects or elements that is well defined, right? Or we can say that set is a collection of objects or elements, and each of the object in that collection has a common nature or a common behavior. So basically, whenever we say set, we usually imagine about a collection, right? Like if we talk about the set of natural numbers, we tend to think about the natural numbers like 1, 2, 3, 4, and this is a collection, right? And so on. Similarly, when we talk about the set of vowels in English alphabet, we tend to think of the alphabets which are also vowels. Like there are 26 alphabets in English language, okay, and 26 letters in the English alphabet, I'm sorry, and out of them, 5 of them are vowels, that is A, E, I, O, and U. So this collection of 5 alphabets is well defined because each of them is a vowel. So whatever our imagination is, whatever collection of objects we try to imagine, we then go on to list them out in some specific ways, right? Like we list them out in the roster form, in which we put curly brackets and separate each element by a comma, right? And we also make use of the set builder form, in which we assume each of the element to be x or y or z for some time, and then we put a colon, and then we write the common nature like x, such that then the common nature of each x, and then we enclose it within the curly brackets. Also, we have seen the open interval and the close interval, right? Like this. This means close interval, and this means open interval, and there will be 2 points here that will be separated by a comma, right? And this is used only in the case of real numbers, right? And we got to know that since we cannot list out each and every real number, so we tend to make use of this kind of brackets. So all these ways, okay, the roster form or the tabular form, the set builder form, okay, and the interval form, all these ways, okay, that we have learned till now, these are the ways to represent our imagination of a collection of objects. Like whenever we say a collection of objects, we tend to think or we tend to imagine about a collection, okay? But all these brackets, okay, all these brackets and commas was very problematic or troublesome for a person named John Venn. Okay, there was a person named John Venn. For him, all these commas was very troublesome. Okay, so this person, John Venn, he said that instead of using so many brackets and commas to represent a set or basically write down our imagination of a collection, we can simply draw a circle, okay? We can simply draw a circle and write all the elements inside the circle. And this is how the idea of using simple diagrams instead of like brackets and colons and commas to represent a set came into picture, which is known as Venn diagrams, okay? Which is known as Venn diagrams. After the name John Venn, because he was the one who invented this idea. Alright, so what is a Venn diagram? Okay, Venn diagram is a way, okay, is a way to represent represent set or a collection of objects, okay, or a collection of objects using what? Diagrams. Okay, not by like using commas and brackets and all of those, just by the use of diagrams. Now this person John Venn, okay, he said that there are just 2 diagrams that can be used. Okay, one is a circle and the other one is a rectangle. So in order to represent set using Venn diagrams, a circle can be used or a rectangle can be used. This is what was told by John Venn. Okay, he said that a circle can be used to represent any set, okay, any set that you have can be represented by a circle. And if in case, okay, if you are dealing in the case of a universal set, or a rectangle needs to be used only for a universal set, okay, let's keep it simple. Universal set, whenever you need to represent a universal set, make use of a rectangle. So now, what is the proper definition of a Venn diagram? Okay, this is kind of a definition of a Venn diagram. Venn diagram, Venn diagram is a way to represent what? To represent set or a well-defined collection of objects, right? This means the same thing, because whenever a collection is well-defined, then only it becomes a set. Okay, well-defined collection of objects using what? Circles and rectangles. Using circles and rectangles, and writing all the elements inside it. Okay, this is important, writing all the elements inside it. So this is the definition of a Venn diagram, the proper definition. So if this is clear to all of you, let's go ahead and take take some sets and try to draw some Venn diagrams. Okay, for each of them. I think I have got a page for you. Yeah, these are some examples. Okay, and here each of this has been given in the roster form. Okay, so we'll try to draw the Venn diagram for this. So what is the rule that John Venn he said, or what is the rule of a Venn diagram? That any set can be represented by a circle, and if it's a universal set, then we need to represent it by a rectangle. Okay, so this is a set that has a name A, and these are the elements, the first 10 natural numbers. So to draw the Venn diagram for this, just draw a circle, name it as the set A, and write all the elements inside it. 1 2 3 4 5 6 7 8 9 and 10. Okay, this is the Venn diagram for the set A. Now if you think about a universal set for this set A, then a universal set for this set A can be the set of natural numbers, right? Because these are the natural numbers from 1 to 10. So if I take the whole set of natural numbers, then it will behave as a universal set for this set A. So what can I write? The universal set or the set of natural numbers is equal to what? 1 2 3 4 and so on. So if you want to draw the universal set and the set A together, how can you draw it? Since the universal set is bigger and it should be represented by a rectangle, so I'll first draw a rectangle in this way. Okay, and then the set A is smaller than the universal set, so A will be inside. 1 2 3 4 5 6 7 8 9 and 10, and this is the universal set. Okay, and all the empty space will have the other natural numbers after 10, like 11 12 13 14, all of this will lie here. Okay, because this rectangle represents the collection of all natural numbers. So this is how we represent a set using diagrams, using circles and rectangles. Okay, now let's look at the second one. B is what? 2 4 6 8 and so on, means this is the collection of all positive even natural numbers. See, they are positive, they are even, and they are natural numbers also. So just draw a circle and write all the elements inside it. Since here it's not possible to write all the elements, so just put 3 dots and done. Okay, and this is set B. And if you want to draw the universal set, once again just draw a rectangle around it and name it as the set the universal set, and this is a set of natural numbers, let's say the same set. Okay, now this one X is what? A set that has been given in the roster form. Here there are some names: Rohit, Virat, Gil and Pant. So to draw the Venn diagram for this, simple, just draw a circle, name it as X, and write the elements inside it. The first element is Rohit, then it's Virat, then it's Gil, then it's Pant. This is it. Okay, just draw a circle and imagine all the elements are inside it. So we don't need to use commas and brackets while drawing Venn diagrams. So it's just an interesting topic in which we make use of diagrams. Okay, now this one, Y is equal to A B C D E F. Okay, the first 6 English alphabets. So draw a circle, name it as Y, because the name of the set is Y, so the Venn diagram will also have the name Y, and all the elements will be inside it. A B C D E F. Okay, now the next one, A is equal to P Q R S T. Okay, so here, okay, let's go back to this one. Here, if you want to think about a universal set for this set Y, then what can I say? U is equal to the set of all English alphabets, right? I can say this because whatever element the set Y has will be present in this set, and this set has something more also. So it's fulfilling the condition of a universal set. So last I'll have Z. So if you want to draw the universal set also along with this, just do this. Okay, draw a rectangle, name it as the universal set, okay, and this is the universal set, and all the other elements like G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z will lie in this region, okay, in the outside region of this set Y. Now the next one is A is equal to P, Q, R, S, T. So to draw the Venn diagram for this, just draw a circle, name it as A and P, Q, R, S, T. Simple, okay. The next one, now this one has been given in the set builder form, right? This is in the set builder form. So we need to list them out in first. Let's try to take out each and every element or see what each and every element in this set is. X such that, okay, there will be some elements here. Each of them has been assumed to be X. And what is the nature of each element? X is a vowel in the English alphabet. So it's simple. A, E, I, O, and U. So if you want to draw the Venn diagram for this set A, name it as A, then A, E, I, O, U. Done. Okay. The next one. Set B is X such that X is a member of your family. Okay. So let's say there are 4 members in your family. It's your dad, then your mom, then your brother, and you. Okay, let's say that you have just 4 members in your family. So this is a set. So to draw the Venn diagram, draw a circle, name it as B, and write the elements or the members of your family: mom, dad, brother, and you. Okay, now the next one is B is equal to 1, 3, 5, 7, 9, and so on. So these are the odd natural numbers. I'm sorry. So just draw a circle B and 1, 3, 5, 7, 9, and so on. Okay, so I hope that each of you got to know how to draw a Venn diagram, or if a set is given to you, how to draw a Venn diagram, and also draw the Venn diagram for a universal set. Okay, it's very simple. Just keep in mind that whenever you have a collection of some objects which is a set, you just need to draw a circle and write all the elements or objects inside that circle. And in case you have a universal set, make use of a rectangle instead of a circle. Okay, now if Venn diagram is clear to all of you, then let me tell you that you have now 4 different ways to represent a set. See, set means a collection of objects, right? And to represent it, first way that you got to know is what? You have got to know the roster form, right? Then you got to know the set builder form. Okay, then you got to know the interval form for the set of real numbers, and finally now you got to know what? You got to know the Venn diagrams. Okay, so these are the 4 ways that you got to know. Alright, now let us go ahead and try to learn the next concept, that is union of sets, intersection of sets, or difference of sets. Okay, so we'll try to learn the next concept, that is union of sets, intersection of sets, okay, and difference of sets. We'll learn these 3 topics with the help of these 4 tools that we have. Tools, you can say. Okay, difference of sets. First, let's talk about the union of sets. Union of sets. Okay, now the meaning of this word union, okay, is to unite. Union, okay, means to unite or to bring together. So union of set means to unite 2 sets or to unite 3 sets, let's say, or even more, and make it into one single set. So if you have 2 sets, let's say A and B, okay, A and B are 2 sets, and A is the set of natural numbers from 1 to 10. So what is A? A is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. A is the set of natural numbers from 1 to 10, and B is the set of natural numbers from 5 to 15. So B is what? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, so this is set A and this is set B. So the union of set A and set B will be denoted as, okay, the union will be denoted as A union B, and this is the symbol. Okay, the symbol to denote union is this kind of U, enlarged U. Okay, this is the symbol. And A union B is a set, and it is a combination of this set and this set. So I need to combine the set A and set B together. This was a separate set, this was a separate set. So I need to combine A and B together and make it into one single set. Okay, so what will be A union B? It will be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the elements of the first set. Then I have the elements of set B, which is what? I'll not repeat the elements. See, 5, 6, 7, 8, 9, 10 is here also. So I'll start from 11, then 12, then 13, then 14, and then 15. So this is the union of set A and set B. Now, if you look carefully, okay, I had both set A and set B in the roster form. See, this is a roster form, and the union also is in the roster form. And we know that while writing a set in the roster form, we cannot repeat elements. So when I combine set A and set B into one single set, okay, I have not repeated any of the elements twice. Okay, now let's try to think in terms of Venn diagrams. Okay, this is very interesting. Let's try to think in terms of Venn diagrams. Let's first try to draw the Venn diagram for the set A. So for the set A, what will be the Venn diagram? I'll draw a circle, I'll name it as A, and I have the elements inside it: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is the set A. Okay, now the Venn diagram for set B will be what? For the set B, I'll just draw a circle. This is set B, and I'll write all the elements inside it: 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Now, if you try to draw the Venn diagram for A union B, then you need to combine both the circles, right? But wait, okay, here since some elements of set A, okay, some elements of set A and set B are common. See, 5, 6, 7, 8, 9, 10, 5, 6, 7, 8, 9, 10, these are common. And that is 5, 6, 7, 8, 9, 10 is present in both the set A and the set B, right? So to draw the Venn diagram for A union B, we will draw it as this, in this way. Okay, this is set A and this is set B. Now, what are the common elements? They are 5, 6, 7, 8, 9, and 10. So I'll write the common elements here: 5, 6, 7, 8, 9, and 10 in this common region. Okay, in this common region. See, this is a part of the set A also, this is a part of the set B also. Now the other like elements are 1, 2, 3, 4 on this side, that purely belongs to A, and 11, 12, 13, 14, and 15 that purely belongs to the set B. So in the diagram of A union B, this is the diagram for A union B, okay, there will be a common region. This is the common region, okay, and in this common region we will write the elements that is present in both the set A as well as in set B. So this is it. This is the Venn diagram for A union B for the two sets A and B. Okay, this is the Venn diagram for A union B that we have taken as an example. Now all of you must be thinking of some other possible diagrams or combinations of two circles, like how I've combined two circles here. Or in case if you are not, then it's okay. Let's do one thing. Let's take an example and try to find the union of two sets. Okay, let's take an example here. Let's say we have two sets, A and B, once again. Okay, A and B, and A is the set of vowels in English alphabet and B is the set of all English alphabets. So in the roster form, set A is what? A is a set of vowels, so A, E, I, O, and U, these are the elements of the set A. And B is a set of all English alphabets, so B is what? A, B, C, D, and so on until Z. Okay, now if you try to find the union of set A and set B, that is, if you combine set A and set B into one single set, we will have what? A union B is equal to, if I combine this, A, B, C, D, and so on until Z I'll get. Why? Because if you look carefully, okay, all elements that is present in the set A is also present in the set B. So when I combine both the sets, I will eventually get set B itself. In other words, we can say that A is a proper subset of B, right? A is a proper subset of B. I can say this also because all the elements that is present in the set A is also present in the set B. So now, if you try to obtain the Venn diagram for A union B, okay, then let's first draw the individual Venn diagrams for set A and then for set B, and then combine both the circles. So the Venn diagram for set A will be what? Just draw a circle, name it as A, and write all the elements inside it: A, E, I, O, U. For B, it will be what? Draw a circle, name it as B, and write all the elements inside it, A, B, C, D, E, and so on until Z. Okay. Now, if you combine both the circles, or basically do A union B, okay, if you combine both the circles or do A union B, what will be the Venn diagram? It will be like this. Okay, this is the set A, that is smaller. Okay, set A is smaller, it just has 5 elements, set B has 26 elements, so set B is bigger, and all the elements that is present in the set A is also present in the set B. Okay, so this is A, E, I, O, and U, and all the other elements will be present here. So here, if you look carefully, since set A is a proper subset, okay, set A is kind of a proper subset for the set B, or you can say that since all elements of set A is present in set B, and set B also has some more elements, okay, so circle A will lie inside the circle B, and the circle B will be bigger. Okay, the circle A will be smaller and circle B will be bigger, so that the empty space present in B denotes the other elements set B has. Okay, so until now, if we talk about union of two sets in terms of Venn diagrams, we have seen what? We have seen two types of diagrams. One is this, okay, where some part is common. Okay, this part is common, and we have also seen this one in which everything is common, like whatever was present in set A was also present in the set B, and set B was bigger. So these are the two types of diagrams that we have seen until now. Now if we take another example, okay, let's take another example. Let's say we have two sets. Okay, example, this is a set A, which is the set of natural numbers from 1 to 5, 1, 2, 3, 4, and 5. And there is a set B, which is also 1, 2, 3, 4, and 5. So basically what I want to say is, if I take an example in which both the sets are equal, then let's see how the Venn diagrams for A union B will be like. Okay, so let's first draw the Venn diagram for set A. For the set A, I'll draw a circle and name it as A. I'll write all the elements inside it. For the set B, I'll draw a circle and name it as B, and I'll write all the elements inside it. Okay, so the Venn diagram for A is this, and the Venn diagram from B is this. Now if you try to obtain the union of A and B, okay, union of A and B, A union B, that is, it will be as what? One circle on top of the other. Okay, one circle on top of the other. I have not drawn the circle properly, I'm sorry, but one circle should be exactly on top of the other, and each of the circle is of the same size. Okay, so here, since both the sets are equal, so we will have two circles of the same size and one top of the another. Okay, all right, so this is set A and this is set B, and the elements are 1, 2, 3, 4, 5, and A. If you want to write the A union B in the roster form also, then A union B is what? 1, 2, 3, 4, and 5, because I cannot repeat any elements. Okay, so this is the third type of diagram that we have seen. First one is this, that has like two sets has something in common, not everything is common. Now I had this scenario where one set was a proper subset of the other. Okay, this was A, this was B, and now when I'm combining two sets, or I'm trying to find the union of two sets, and the two sets are equal, then I'll have something like this, one circle on top of the other. Okay, now let's take another example. Okay, let's say we have two sets. There is a set A, which is this set of natural numbers from 1 to 5, 1, 2, 3, 4, 5, and there is a set B, which is what? 6, 7, 8, 9, and 10. So the Venn diagram for set A is what? I'll draw a circle, I'll name it as A, and I'll write all the elements inside it. The Venn diagram for set B is what? I'll draw a circle, I'll write the name of it, and I'll write all the elements inside it. Okay, so what will be A union B? Okay, in the roster form, it will be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's simple. Just combine all the elements that is present in set A and that is present in set B, and make sure not to repeat any elements. In terms of Venn diagram, if you try to combine both these diagrams, A union B will be just like this. Okay, this is A and this is B. That is, A union B, okay, it will be just two circles nearby each other, but these two circles will not touch each other. Why? Because set A, okay, if you look carefully, set A and set B has no elements in common. Okay, so here comes the concept of disjoint sets. Disjoint sets. Okay, so please make sure to note this down. Two sets, okay, two sets are called as disjoint sets if they have no elements in common, like this one. Okay, if there are two sets, okay, two sets, and they have no elements in common, they have no elements in common, then they are called as disjoint sets. They are called as disjoint sets. Okay, and if you draw the Venn diagram of union of two disjoint sets, the two circles will not touch each other. Okay, so this was the whole idea of union of sets. Okay, so just remember, union means to unite, to combine. So union of set means to unite or combine two or more sets and make one single set. Okay, and while doing union of two sets, we can easily write the roster form of A union B. Okay, like we have done here or here also. Okay, I've done we can do it in the roster form also, and while doing this, keep in mind not to repeat any element twice. Okay, and while doing union of sets in terms of Venn diagrams, we will always have four possible diagrams. Okay, union will always have four possible diagrams. This is the first one, this is the second one, this is the third one, this is the fourth one. This is for what? When the two sets are disjoint sets, they have nothing in common. So the first diagram, okay, this is the first diagram, is when you combine two sets and both the sets have some elements in common. The second one, okay, is when you combine two sets and one set is a subset of the other or a proper subset of the other. The third one is when you combine two sets and both the sets are equal. Okay, and lastly, the fourth one is when you combine two sets and both the sets have no elements in common or they are disjoint sets. Okay, now let's quickly talk about the other concept, the other two concepts. In fact, we have seen what is union of sets, right? The union of sets is clear to all of you. Now let's see what is intersection of sets. Okay, intersection of sets, and also talk about the difference of sets. Difference of sets. For this, let's take this first diagram, okay, of A union B. Let's take this first diagram and we'll try to obtain the concept of intersection and difference from this basic diagram. Okay, so let me draw the diagram here first. This is set A and this is set B, and this is the common region. Okay, this part is the common part. My pen is having some problems, I'm sorry for that. So here, if you look carefully, okay, this region, okay, is the common region to both A. Okay, this region, it belongs to A also, it belongs to B also. So it is common region to both the set A and B, right? And this common region is known as the intersection region. This is the intersection region. Okay, or where A and B intersect. And if you try to recall, this is the region, okay, where we write the elements that is present both in set A as well as in set B, right? So now what do you mean by intersection of two sets? Intersection of two sets, okay, A and B, or intersection of two sets A and B, or it is denoted as A intersection B. For union, it was A union B, like this. So just make this U ulta, so it will be A intersection B, and this is the symbol for intersection. Okay, intersection. So A intersection B is a set, okay, which has what? All the elements that is common or that is present in both A as well as in B. So this is a region, okay. In intersection means, or in intersection of two sets is a set that has all the elements that is common to both set A and set B. Okay, and this is a symbol. Now if this idea of intersection is clear, then try to think, if you have two sets A and B and they are disjoint sets, okay, that is they have no elements in common, then what will be A intersection B? The Venn diagrams will not touch each other. There will be no common region, okay, or the set A and set B have no elements in common because they are disjoint. So A intersection B will be phi. That is a null set or empty set because A and B have no elements in common. Similarly, if you have two sets, let's say A and B, once again, and A is a proper subset of B, okay, A is kind of a proper subset of B, then what will be A in intersection B? It will be A itself. Why? Because A is a proper subset of B. That is, all elements that is present in the set A is also present in the set B, and B has some extra elements too. So the intersection or the common elements of set A and set B, or A intersection B, okay, will be what? A only. It will be the elements that is present in the set A only. And finally, if both these sets are equal, or both the sets are equal, let's say if A is equal to B, this was the case for when A is a subset of B. This was the case for when A and B are disjoint, okay, are disjoint. Now if A is equal to B, then what will be A intersection B? It will be either A or A intersection B is equal to B. You can write this or you can write this also, okay. Now I'll just give you a brief recap of intersection. Intersection means, or intersection of two sets means, where there are some common elements between the two sets, or the common region is known, this region is known as the intersection region. And that is why if we are talking about two disjoint sets, they will never touch each other, or they will have no common region. So intersection of two disjoint sets is always a null set, means no elements. Alright, now let's talk about the last one, that is difference of sets. Difference of sets, okay, let's talk about this topic. So what will be difference, okay, if I have two sets A and B, so what will be the difference of these two sets? It will be either A minus B, right, or it will be B minus A, correct? Difference means minus, so either I can think A minus B or I can say B minus A. So A minus B, okay, it means a set of all the elements, okay, a set of all the elements that purely belongs to set A and not to set B. Okay, A minus B means what? A minus B is a set, okay, like A union B was a set where we combined two individual sets and made into one single set. A intersection B is also a set where I check the elements present in A and the elements present in B. The common I'll bring all the common elements of A and B together and make into one set. Similarly, A minus B is also a set of what? Set of all the elements that purely belongs to the set A and not to the set B. Okay, and what is B minus A? B minus A, it means what? Set of all the elements, okay, set of all the elements that purely belongs to set B and not to set A, okay, not to set A. So this is the meaning of B minus A. Now this can be very easily understood from the Venn diagram, okay. So if you try to recall the Venn diagram in this way, this is the very basic Venn diagram, everyone should keep in mind always, okay. So here, this was a set A and this was a set B. This was a common region, right? This is the A intersection B region, and the whole thing is A union B, okay. But if you look at this part, just look at this part. This is something that purely belongs to A, right? So this region is for what? A minus B. That is, all the elements that will lie here, we can say them what? Elements that purely belongs to the set A and not to the set B, because any element that lie in this region, okay, in this region will belong to the set A as well as to the set B. So this region will not be included, and this region is for what? B minus A, means any element in this region will purely belong to the set B, okay. Alright, so this is the basic theory of Venn diagram and union of sets, okay. Let's go ahead and like try to do some questions mentioned in your textbook and try to apply the concepts that we have learned today, okay. let's see here if I've got the paper for you. Yeah, this is the sheet number 1. So here let A is this set. Okay, A is a set that has 4 elements, 2 4 6 8, and B is a set which has 4 elements, 6 8 10 and 12. It says find A union B. So I need to combine the two sets because it says union. Okay, A union B, so means I need to combine A and B together and make into one set. So what will be A union B? It will be what? If I do it in the roster form, then it will be 2 4 6 8, the elements that is present in A. Okay, now look at the elements present in set B. 6 8, I have 6 and 8. Okay, I'll not repeat it. Now I will include 10 and 12. So this is A union B. And if you want to draw the Venn diagram, the Venn diagram for set A is what? I'll draw a circle, name it as A, 2 4 6 8. I'll draw the set B, 6 8 10 and 12. To combine both of them, I'll do what? Since they have some elements in common, so I'll keep a common region. 6 and 8 are the common elements. This is a set A, this is a set B. There is 2 and 4 that purely belongs to the set A, and there is 10 and 12 that purely belongs to the set B. So these are the 4 elements that is in set B, and these are the 4 elements that is in set A. So this is what? A union B. Okay, now let's look at question number 2. Here A is A, E, I, O, U, and B is what? A, I, U. It says show that A union B is equal to A. So this is what we need to show. This is the left hand side and this is the right hand side. So if I take the left hand side, this is what? A union B. So let's try to solve, or let's try to do A union B. Okay, so what will be A union B? It will be like combination of both the sets. So let's write all the elements of A first. A, E, I, O, U. Now let's try to write the elements of B. A, I already have a I have a I, U, I have a U. So this is it. Now this is what? The set A itself, and which is the right hand side. Okay, so hence we prove that A union B is equal to A, since left hand side is equal to right hand side. Now the next question is, let X equal to Ram, Geeta, Akbar. Okay, X is a set that has 3 names, Ram, Geeta and Akbar. Be the set of students of class 11 who are in the school hockey team. Okay, these 3 people are in the hockey team. Let Y is equal to Geeta, David and Ashok. Be the set of students from class 11 who are in the school football team. Okay, these 3 are in the school football team. Find X union Y. So what will be X union Y? Combine both these 2 sets. Okay, the first set has Ram, Geeta and Akbar. Okay, and the set Y has Geeta. I have a Geeta here. I'll not repeat, or I'll not write once again Geeta. I'll write the next element David, and I'll write Ashok. So this is the union of set X and set Y, and if you try to draw the Venn diagram for this, it will also look like this, because there is one common element, that is Geeta. This is X and this is Y, and the other elements will be on the other sides. Now here it says consider the set A and B in question 1. This is the question 1, and find A intersection B. So what is A intersection B? It means elements that are present in set A and set B and make it into one set. So what is A intersection B? This is elements that are common. 6 and 8 is present in both A and B, right? So I'll write 6 and 8. So this is the set for A intersection B. Okay, now the next one here, let A is 1 2 3 4 5 6 7 8 9 10. Okay, B is 2 3 5 7. Okay, find A intersection B. So A intersection B means all the elements will make a set of all the elements which is present both in the set A and the set B. So 2 is present in the set A and in the B also. So 2 is fine, 3 is fine, 5 is also there, 7 is also there. So I'll write 2 3 5 and 7. Now this is basically set B itself, right? So here B is a what? Proper subset of the set A. See, all the elements that is present in the set B is present in the set A, and A has something extra also. So the Venn diagram will be like this. Okay, this will be B and this will be A now, like this. Okay, B will be inside because B is smaller, and all the elements that is present in B is also present in A. A has something extra. Now let's look at this one. A is 1 2 3 4 5 6, B is 2 4 6 8. Find A minus B and B minus A. So here we are talking about difference now. So what is A minus B? A minus B means all the elements or the set, okay, a set of elements which purely belongs to A. Now 2 1, it purely belongs to A. See, 2 it is there in set B also, so I'll not include 2. 3, it's only present in the set A. 4, it's present in set B also. 5 is present in set A only. 6 is here also. So I'll just include 1, 3 and 5. 1, 3 and 5. So this is A minus B. All a set of all the elements that purely belongs to the set A. Okay, if you want to draw the Venn diagram also, let me draw this. This is set A and this is set B. Now the common elements are what? 2, 4 and 6, right? Here I have a 8. So 2, 4, 6, 8 are the elements of set B, and 1, 2, 3, 4, 5 and 6 are the elements of set A. So see here, 1, 3, 5 are the elements that purely belongs to the set A, and 8 is the element. So B minus A will be what? Just 8. Singleton set, one element. Okay. So Venn diagrams makes it easy for all of you to do things, or to do many things. Okay. Now there is a two sets V and B. I need to find V minus B and B minus V. So what is V minus B? Elements, or a set of elements that purely belongs to the set V. So draw the Venn diagram for this. It will be easy for all of you. Okay. Now they have some elements in common. See, A and A common, I and I common, U and U common. So I'll have to draw a Venn diagram like this. A, I and U is common. This is set V and this is set B. So here I'll write E and O, and here I'll write just K. So A, I, U, K. A, I, U, K are the elements in set B. A, E, I, O, U are the elements in set V. So what is V minus B? These two elements, right? Simply E and O. And B minus V will be what? Just K, because K is the only element that purely belongs to B. Alright, now let's look at some properties, okay, of union of sets. Let's talk about some properties of union of sets and intersection of sets. So first, let's look at the properties of union of sets. Okay, let's talk about the properties of union. Properties of union of sets. The first property is A union B is equal to B union A. So you combine A with B, or you combine B with A, that's the same thing. So this is kind of a law. Okay, this is the commutative law. You don't need to recall, or you don't need to remember all this. Okay, these are just properties or behavior. Okay, now the second one is A union B union C. Means first you do, since there is a bracket, okay, so first you need to do A and B union, and then this will be one set, right? And then if you combine it with C, this will be equal to it. If you do it in this way, first you do B and C, and then you combine it with A. So this is kind of associative law. Associative law. Why? Because you associate A and B together, and then you associate C. The result that you will get will be same as when you associate B and C together first, and then you associate it with A. So this is associative law, how you associate. Okay. The third one is A union phi. Now tell me, A is a set that can have any elements, and there is a phi. Phi means null set. So if you combine a null set with any set, you will get the same set, right? So this is kind of an identity. So this is law of identity. And phi is what? Phi is the identity of union. Okay, always remember this line. Phi is the identity of union. Now why it is called as identity? Because see, whatever set you take here, like X union phi will be X, Z union phi will be Z, means whatever set you take, the identity goes on, okay, to the result. That's why it's called as law of identity. Now the number 4 is A union A. Think about this. There is a set A and there is another set A. Means both the sets are same. Combine both the sets, you'll get the set A itself, the same set. Okay. Now this is what? Idempotent law. Idempotent law, or idempotent law, some may say. The fifth one is U union A. Now U is what? Universal set, that is bigger, and there is a set A, which is obviously what? There is the set A, whatever elements the set A has will be present in the universal set also. So when I combine both the sets, I'll eventually get the bigger set only, right? So it will be the universal set. So this is the law of U. And now the union of two sets in the set builder form. Okay, this is very important. Please make sure to note this down. The union of two sets in the set builder form. Okay, if I have two sets A and B, let's say, then A union B is equal to what? X, such that X belongs to A or X belongs to B. This is the way we write it write union of sets in the set builder form. That is, A union B is such a set. Okay, A union B will have some elements, and each of the element has been assumed to be X. Then X or that element will either, okay, here whatever element is present, each of the element will either belong to the set A or to the set B. So this or is very important. Whenever we talk about union, there is a or. Okay, now let's talk about the properties of intersection. Properties of intersection of sets. Okay, the first property is A intersection B is equal to B intersection A. This is commutative law. Like this one. Okay, the second one is A intersection B intersection C is A intersection B intersection C. So you associative law, like how you associate the two sets first. You first associate A and B, and then you associate it with C. So whatever result you'll get will be same as this one. So this is what the associative law. Okay, associative law. The next one is phi intersection A is what? Now think about this. Phi is a set that has no elements, and A is a set that may have some elements. But intersection, is there any common element between an empty set and a set? No, right? So it will be phi once again. And then U intersection A. Think about this. Universal set and a set A. What will be the common elements? The elements that set A has. So this will be A. Okay. So this is law of phi. Okay. Law of phi, and this is law of U, or the universal set. Now the fourth one is A intersection A. A and A intersection will be what? A itself. Okay, so this is idempotent law. And the fifth one is A intersection B union C. This is important. Okay, this is A intersection B union C, like A into B plus C. How will you do this? You'll break it down into A into B first, the plus will come in between, and then A into C. So here it will be A intersection B first, okay, and then union will come in between, and then A intersection C. So this is the distributive law. This is important. Okay, how you distribute A with B and C. A with B first, and then A with C. This is known as a distributive law. And intersection of two sets in the set builder form. Okay, if you have two sets, let's say A and B, then A intersection B is what? X such that X belongs to A and, okay, X belongs to B. That is A intersection B. Okay, this is such a set where each of the element, okay, has been assumed to be X for some time. Then each of the X, or the element that is present, okay, here is present in both the set A and the set B. Okay, so this and is very important, so keep this in mind. Please make sure to observe this difference as to how we write union and intersection of sets in the set builder form. Okay, in union we have a or. Okay, this is or is for union. Or means what? Whatever element I'll have in this set A union B, okay, whatever element I have, each of the element will either belong to the set A or to the set B. But in this case, whatever element I'll have in this set, each of the element will belong to A, and also it will belong to the set B. This is what we make use of AND here. Okay, so this is it for today. But before we wrap up this lecture, okay, this has gone too long, but before I wrap up this lecture, let me tell you a very basic diagram to remember all that we have learned today. Okay, so this is the diagram. This is a very basic diagram. Okay, these are two sets A and B, and let me also draw a universal set here. Okay, so this is the universal set. Now this region, this is the A intersection B region. Means if A intersection B means a set that has all the common elements between the set A and the set B. So this is the intersection region. This region is B minus A. Okay, elements that purely belongs to the set B. This is what? A minus B. And this whole thing is what? A union B. Okay, and if we have three sets, okay, we have until now seen just two sets. So let's say I have three sets A, B and C. Then How will I draw the diagram? In this way. And if I draw the universal set, I'll draw a rectangle in this way, and this is the universal set. This is A, this is B, and this is C. Okay, this whole thing is what? A union B union C, and this common region. Okay, look at this common region. This common region here, this is a region that belongs to A, this region belongs to B, this region belongs to C also. So this region is A intersection B intersection C. Okay, so this is it for today. Thank you so much for watching the lecture. We'll see you in the next video. Thank you.